We're going to talk about model context protocol today, specifically the transport layer between model context protocol servers and clients. I'm going to be showing you guys how you can implement your own transports, and specifically, we're going to be embedding a model context protocol server in the same process as the clients. We're going to be doing this all in Typescript. Welcome back to Tani Codes. My name is Tani. Let's jump right into it. So on my screen here, I'm looking at the GitHub for model context protocol servers, and this is basically an index of a bunch of popular open source model context protocol servers. And this isn't going to be a video about specifically what model context protocol is. If you guys are interested in that, let me know in the comments and I'm happy to do one. But any of these servers, you can basically plug into Claude Desktop or a similar app and integrate it into your application. And so for instance, if we look at the Filesystem server, this is going to allow users to do stuff like create directories, list directories, kind of basic file system operations on their computer. And I actually downloaded the source code for this server. And let's go over to WebStorm now. And if we take a look, here is the source code just in my editor. And as we can see, we're importing a bunch of stuff from the Model Context Protocol library. And one thing I want us to pay attention to is this stdio server transport. Now, the protocol that Anthropic released is language agnostic. It's server agnostic. And what I mean by that is you're able to configure the client and the server in a lot of different ways. You could have the client and the server running on the same machine, but in different subprocesses. So that would be like Claude Desktop, and then you launch a Model Context Protocol server running in a different process. And that is actually the default for Claude Desktop. And if I pull up my terminal here, I will show you a configuration that I have to actually run this Model Context Protocol server, the Filesystem server. If we look at what it's doing, it's actually running an npx command that will invoke the server. And so what that means is when Claude Desktop is running and you want to actually use this MCP server, it has to launch it as a subprocess, manage that subprocess, and they're actually communicating over standard in and standard out. So their streams are connected in that sense. There's no sockets. There's nothing fancy. It is happening over IPC. Now, you're not limited to stdio server transport. You're not limited to standard in and standard out as the transport layer. You can implement your own transport layers. Another popular one is called SSE. So if we actually look at the dependencies here, we're looking at the Model Context Protocol library code. You'll notice that there's one that's called sse.js. And this would be like running a web server to serve the Model Context Protocol API. This is SSE, by the way, stands for Server Sent Events. If we go down here, this guy is also going to be implementing the transport class. And again, the transport is the base interface. So if we go over to transport, we'll see that any transport layer just needs to implement these methods. We have start, close, on close, et cetera, et cetera. The main ones that we care about are going to be send and on message. And I'll explain later what we're going to do there. But before we do that, let's actually go back to the file system server code and let's scroll down all the way to the bottom. And this is the code that I just took straight from GitHub. I haven't done anything to it yet. If we take a look at the run server function, one of the issues with this script as it's written now is it forces you to use standard in server transport. And what that means is you must invoke this as a subprocess. And then your MCP client would actually need to also use stdio transport, and we need to hook into the standard out stream for this process. That can work, but for something like file system, really, like, there's not a lot of state in the server. Actually, all this server is really just embedded logic. Like, it's getting file info, it's reading through files, it's searching through files in our directory. And if you're writing a client application, like if you don't actually want to use Claude Desktop, it's kind of annoying that you have to run this as a subprocess, especially if you're running a Node.js application. This is something that you should be able to just embed in the app. And in fact, that's what we're going to do today. I'm going to embed this server into the same process as a client. And to do that, we're going to implement our own transport layer. So anyway, this is the server. If we look up here, like, we're just inspecting the source code. And I always recommend, by the way, on this channel to look at the source code. It's very helpful. We'll notice that these are the tool descriptions. These are the tool definitions. So when we send a request to the LLM, we need to include this entire list of tools along with the descriptions. And then when the user sends a request, the LLM will have this list and it will understand if it needs to or when it needs to use one of these tools. So if the user's request says, hey, I want you to read this file and let me know if it mentions a certain thing, it's going to read this description and figure out on its own, oh, well, I better call the read file tool. And that's kind of how the tool usage works. But anyway, the problem with this code is that it's actually forcing us to use stdio server transport. So why don't we pull this up into a parameter? We're just going to call this transport. And I don't want this to be an any. I want this to be a transport. And let's go up. And we also need to import the transport object. So I think that's going to come from, let's see. I got to find it over here. Where are we going to get transport? Let's see. Can we do the import? Please. Okay. Thank you, WebStorm. We have the transport up there. And we don't need this. There we go. And the default is fine. Actually, let's get rid of the default. So now I made this more generic. Before, you were actually forced to use the SEIO server transport, and that's going to be just way too restrictive for us today. And now that we have that set up, yeah, let's get rid of run server. What's wrong with this? Okay, so now I don't have the argument there. So let's actually remove this run server. I don't want to do that. What I'm going to do instead, and by the way, I'm actually going to rename this run Filesystem Server. I think that's going to make things a little easier going forward. I've created this main.ts, which is currently completely empty. And what I want to do now is instantiate an MCP client and then instantiate the server and then actually have them communicate with each other. So let's do that. I think what we're going to want to do is import the client. So let's say const client equals new client. And let's see if WebStorm can find this guy. Yes, it can. So thank you. And the client, what arguments do we need? We need implementation. So I think that's going to be one of these guys. Okay, so anyway, this is how you instantiate a client. I had to go look that up. But basically, we give it a name, a version, and we're just going to leave the capabilities field here blank. And what you need to do to initialize a client is you're going to await a client.connect. And you'll notice that the argument we need here is a transport object. And that's what we're going to need to fill in with the server. So before we do that, why don't we actually grab a server? So let's call a server. That's where we're going to import this run file system server. So let's go ahead and export that guy. And we are going to do run file system server. And this also we need a transport. So the client and the server are going to communicate via a transport object. And let's go and take a look at this interface. I know we touched on it briefly, but we go to SEIO server transport, and we're going to go and jump to the definition of the transport. And the thing that's nice about this transport is that it's generic. This is what actually enables us to write clients and servers that are on different languages, that live on different computers, and that have different deployment strategies. But this send method, whenever you call into an API using the MCP client, ultimately that's going to call the send method. So if we actually go back to the main.ts and we await something like client.listTools. ListTools is one of the APIs. A MCP client can ask a server to list its tools. And if we actually look in the definition of ListTools, which unfortunately is going to be in this index.js, and let's look for ListTools, we'll notice that what ListTools is doing is calling into a lower level request method. And the first parameter is going to actually be the message that's getting sent. So all of the communication between the client and the server, that is happening with JSON. And we can see here that this is what the method looks like. Like we're giving it the name of the method to call and then the arguments. So nothing super fancy here. And if we actually look at this.request, and again, we're going to have to, I guess, go into, whoops, that's the wrong type hint. Let's actually go into, I think this is coming from, looks like protocol. So yeah, so over here, if we go to protocol, shared protocol JS. So we are under here. This is where protocol is. And it is actually very nice to have the full dependency tree up here so we can poke around. But regardless, we are going to go down and there should be a method called request. And yes, I believe this is it. So sends a request and wait for a response. Yeah, so this is actually how the request is implemented. And I know there's a lot of stuff going on, like we're doing message ID, we're incrementing stuff. This is all fine. We don't need to worry too much about it. But I want us to look at line 284 here. And this is where we're actually referencing the transport object. When we call ListTools, which will go to the server, ask it to return the array of tools it has, which in this case would basically just be this dictionary here, this object that has all the tools. That's what we're actually looking for. That's achieved via the ListTools API call that's exposed in the client. If we go to index.js, ListTools will call the lower level request method, which is found in this protocol.js. And in addition to doing a bunch of other stuff, a bunch of bookkeeping about the message ID and stuff like that, it's also going to call into its transport object's send method. And if we look at the transport interface, that's actually what's going to go on here. So when we're talking about linking this up for the same in process, when we're talking about being able to communicate between the client and server within a single process, what we need to do is actually work with a transport object, and we need to implement a transport object that's going to work. So why don't we actually go do that now? And I'll show you guys what I mean. So let's actually go and we'll quit out of this, and we're going to create a file called LocalTransport.ts. And what we're going to do here is we're going to make a class, and we're going to export class. This is called LocalTransport, and it's going to implement the transport interface. So let's see if we can pull this guy in. That looks right. And then let's actually go and implement some methods here, implement interface. And now we have a bunch of stuff going on. So now we've actually implemented the interface. Don't care about start. Send message. Let's actually just console.log that message. And we'll go here. And I guess we're concerned await, or we concern promise.resolve. And we'll do the same thing here. Cool. So now we're actually compliant with the interface. Let's go back to main.ts. And what are we going to do? We're going to create a local transport. So local transport is going to be a new local transport. Thank you. And then we are going to pass this into both the server and the client. And this is not going to work, but it's at least going to allow us to see sort of how messages are flowing through the system. And now that we've done that, let's go ahead and run this in the debugger. And keep in mind, I've added a breakpoint here. And the reason we're doing this is because we want to understand how the messages flow through the system and how we're going to actually be able to implement an in-memory transport. So let's actually run this now. Let's see if it works. Okay, so the issue actually is that the file system server is set up as a script. It's not really set up to be run as something you import, which is really annoying. And if you look up here, it's actually expecting like a list of arguments, which is really super annoying. So why don't we cheat a little bit? And what we're going to do, where does it read the args dots? The first argument that it's getting is supposed to be the allowed directories. Like this is a server that you have to whitelist certain directories. So why don't we actually go find that? So where is args? We're gonna look for args here. And where are we? Okay, so we can get rid of that. I don't need that. That's just some validation. We're gonna cheat and get rid of that. Okay, so instead of args.map, let's actually just define it up here. So here's what we're gonna do. We're gonna get rid of args. We're gonna do const allowed. Yeah, we're just going to hard code the allowed directories. So this is going to be just a list. And let's actually go ahead and just use the current directory that I'm working in. I think this is going to be easier. So let's go and do this. And this is the other thing with some of the MCP servers is I wish they were better set up to be actually imported and used in a project. I mean, it's nice that this code is free and we can just download it, but it's really only usable in Claude Desktop. And you have to go and do this kind of modifications. And to be honest, this is something that I would probably have the AI do. And I might if this also has an issue. But anyway, hopefully that worked. Let's run a debug again. And yes, okay, so now we are actually in the code. We are in the debugger. And if we look over on the left-hand side here, we are in the connect call. We are connecting via the local transport. So let's go up here. And we should actually see a message, JSON RPC request. And yes, the initialized message. So when the client first connects to the server, it does so by sending one of these initialized messages. And this is just one of the many messages that has to be sent. It's a very stateful protocol, which I know some people don't really like, but regardless, this is how it works. So we're calling transport.send, and let's actually go and resume the program. And now we are in the send method of the transport object that we created. So that's pretty nice. We are in the send method, and yes, it's that same object. So let's hit play, and we should actually... Okay, so what's happening is Okay, so why is this blocked right here? So what's going on is we are awaiting client.connect. The client is sending a message to the server expecting a response. And yeah, okay, you can see what happened here. We got a cancel notification. And because the transport implementation is not actually doing anything, because the send method didn't do anything other than log the message to standard outs, the server is never going to respond. And because of that, this program is going to block. And it looks like what's happening here is they've set up some kind of timer, some kind of timeout, like 5 seconds, 10 seconds. And if you can't actually get a response from the server within that time, it looks like now what's happening is the client is sending a message to the server that's saying, actually cancel that. You're taking too long. So that's why we're seeing this cancel thing here. If we press play, now we actually see that the process died. That's exactly what's happening. There's some kind of timeout, and it is preventing that message from getting sent. So what do we need to actually do to link up the server and the client? Let's go back to the transport interface. So send, I think, is pretty clear. This is where we actually need to take the message from the client and get it to the server somehow. But let's take a look at onMessage. So onMessage says this is a callback for when a message is received over the connection. So if you think about it, the client is going to call its send method when it wants to send a message to the server. The way that the server receives that message is somebody or something has to call its onMessage handler. So if we actually go up, I think what we need is not just one local transport, but we need 2 local transports, and they need to be linked up. So why don't we do something here? We're going to do private local transport other. So we'll call it twin local transport because they're kind of twins, you know, they have to be working together. And that's going to be of type local transport. And what's going on here? It's never accessed. Okay, it has no initializer. And so, and then I'm going to explain why we need this in a second. We need a function called add twin. And that's going to take a local transport. And what that's going to do is set the twin local transport equal to the one that's provided in. And then what we're going to do here is in the send method, we are actually going to call the onMessage handler of the twin local transport. So this is us just manually shipping the message across from the client to the server. So anyway, let's go back. And what's going on here? Oh, I see. We'll make it optional. We need to make it optional. See, I love TypeScript, but it is a little strict, at least for some of this one-off scripting stuff. So anyway, we're going to create a local transport here, and we're going to call this the server local transport. And then we're going to create also a const client local transport. And then what we're going to do is, okay, server local transport, add twin, and we're going to add the clients. And then likewise, we're going to add the server to the client. And I know this might be a little confusing, but anyway, we're going to add the server local transport here. And then the client, we're now going to add the client local transport. And now we can rerun this entire thing. And we'll do that with Control D. Okay, so now, again, we're in the send method again. We were just here earlier. Let's hit play. Now we are in the send method of the local transport object. But now instead of just logging the message, we're actually going to call the servers on message. So let's go ahead and do that. Hit play. And now if we look, we're back in here. And this is a new message that we didn't see before. So before we saw that initialize message, and then we also saw that notifications canceled message because the client was telling the server, hey, you've taken too long to respond. I'm canceling this connection. But now if we actually look here, we are seeing a message that says protocol version and capabilities. And we see an empty tools object, server info. And so this is actually the file system server. This is the file system server that we're seeing here. And if we look down where it's coming from, you can see in the call stack that this is indeed the on message handler. So some of the stuff is missing here. Some of the stuff the debugger is missing, but regardless, like ultimately what's happening is the server is actually responding with its initialized message. They are doing a handshake. It is providing the protocol. So let's hit play here. And now we see, okay, notifications initialized. So that's good. We hit it again. And now we are finally calling the tools list function. So again, if we look at the debugger, we are now at list tools. And let's see if this is going to work. Let's hit play. And yes, we're in transport send. We are calling the list tools message. And now we actually are getting a response. And if we look here again, where are we? Okay, so this is the server's, the client's local transport. This is the server's local transport. And the server is now responding with the full list of tools. And if we look here, we see read file, read multiple files. Again, this was configured in the file system server. Like this is all just stuff configured in the file system server. And then if we go up here, we can see that we're responding. So let's hit play. And now the process will actually end, which is nice. But let's actually have it printed out. So let's go back into main and we'll say tools equals await. And then let's console.log that. And let's just run it regularly. And we see, yes, we see the list allowed directory. So now we've successfully connected the client and the server. We've actually successfully implemented our own transport. And it was not too scary. Now let's try something else. Let's go back here. We want to do it in the definition. So list allowed directories and we'll say LMAO. So that's going to be the name of the new tool. List allowed directories LMAO. And let's run this now. And yep, so that's what's going on there. So now we can actually run this file system server as an import in our application. We do not need to run it as a subprocess. We do not need to stand up an HTTP server. We can literally just embed it. And although they're still using this kind of overpowered transport interface, which seems a little ridiculous if they're in the same process, the framework itself is still very flexible. And that's what is really nice about this. So as I was shooting this video, one of the things I noticed is this local transport does actually exist already. I was having this trouble finding it in their documentation, like their official documentation. But if we go again on the left-hand side and we look at the source code for the Model Context Protocol SDK, you will notice down here, there is a transport called in-memory. There is an in-memory transport. And let's actually look at the interface here from Typescript. And one of the ways you do it is a create linked pair. Why don't we redo this entire script, but use the linked transports? So instead of doing this, so let's go ahead and like literally just comment all that out. Let's comment all this out. Yeah, that's commented out. And let's go in and say const transports equals create, what was it called? In memory, create linked pair. That's going to be a static method, in memory transport. So let's go copy this, and what was it? Create linked pair. Okay, we're going to have to import you. So now we have const server transport is going to be the first one, client is going to be the other one. And now if we run this, that also works. So luckily Anthropic or somebody who was maintaining this library included this stuff. But now we know how it works. So if we go into, for instance, inmemory.js on the left-hand side here, and we go down, look, if we look at what's actually going on in create linked pair, they're doing exactly the same stuff we were doing in the local transport. So instead of having to, explicitly call the add twin method, now they're just doing it via a static method, which is nice. And there's also some extra error handling and message queuing. So this is probably going to work a lot better. But yeah, exactly. Like this is what's happening in the send method. So let's go here. We are actually calling send. Like we're literally just sending the message to the other transport. And again, I guess if it's offline or something, that's where the message queuing is coming in. But this is all you need to do. This is all you need to do to implement an in-memory transport. And it does work. Like you can actually list the tools. Now, of course, this is not a real application. This is not really a usable MCP client. You'd probably want a chatbot setup, and you probably don't just want to list the tools. You probably want to listen to user requests, hook it up to an LLM, and have the LLM decide what tool to run, but then additionally, actually go and execute the tool on the server. If that's something you guys are interested in, let me know in the comments, and I'm happy to make a video. I'm going to end the video here. Thanks for watching. We appreciate you on Atomic Codes.